Hello friends, hello students. We are meeting again for our next lecture of Introduction to Green Chemistry. In the last lecture, we have seen the purpose of green chemistry, and in short, we can say that green chemistry is a sustainable chemistry. So, practice of green chemistry in the industry begins with understanding, realizing that production, processing, and use and eventual disposal of chemical products can cause harm to environment. So, whenever you begin any chemical industry, here where to understand how it is going to damage our environment. So green chemistry, green technology, and green chemical engineering must go hand in hand to modify the or to redesign if necessary the existing products and in manufacturing pro- procedures with objective of minimizing waste generation, use, or generation of hazardous material. So this statement you might find it confusing. I will break it in short and I will explain you that green chemistry is a fundamental science. Chemistry itself is a fundamental science. So that fundamental science gives you technology. So green chemistry gives you green technology. Okay, and this technology leads to engineering. So green technology leads to green chemical engineering. So here one should think in such a way that they cannot be separated apart. So whatever is new idea is developed in green chemistry, so without hampering, without damaging the purpose of that process, technology should be developed. Okay, means in industrial chemistry you might have we have discussed that in lab we prepare any chemical by one method, but when you go to industrial scale you have to change the conditions. Sometimes you may have to change the temperature, catalyst, solvents. There are n number of things, but no doubt you have to consider that, but don't focus only on economical aspect of the process development. Here you have to take care. No problem if you are changing solvent, no problem if you are changing catalyst, no problem if you are changing the process bit, so that you will get the desired product or good yield. But that should be taken into account that it should not have any waste product, and that waste product if at all is going to form, how you can recycle it, how you can carry out the process using minimum amount of energy. So all these things you have to consider not only in green chemistry but in green technology, and when you go to engineering in green chemical energy. That is the meaning of this statement which I have read here earlier. So this green chemistry or sustainable chemistry, you cannot separate. This figure itself tells like a Venn diagram that sustainability is a bigger concept. Okay, sustainability does not only depend on technology or particular chemistry. It depends on many other things like physics, chemistry, biology. It has to take into account all the aspects of five sphere, you can say. So here you can say that green engineering technology and green chemistry is a part of sustain. So they go hand in hand. So there is a relation between them. So this does not mean that industry has to suffer economically. We are thinking so because we have we have constructed our plants just to taking into account the desired product, not the environmental aspect. So we have to bring the change. So in this transition, no doubt there will be some economical loss, but for future generation or in the future development, such economical loss you will never find. On the other hand, green chemistry is about increasing the profits or promoting innovations. At the same time, human health and environments means here we are not saying that we have to totally neglect the financial or economic aspect. No doubt you have to take care of that, but at the same time equally important is human health and environment. So if you can develop such technology, such engineering, such chemistry, such process which will take care of all these aspects, then it is called as green chemistry, and then it is called as a sustainable development. Okay, so green chemistry develops and applies chemical knowledge for production. Okay, so here you have to, no doubt chemistry means you have to produce something. Okay, green chemistry is developed for that purpose only, and ultimate disposal of chemicals in such a way that consumption of material is minimized. Means here green chemistry focus on consumption, minimum consumption of material, exposure of living organism to toxic substances is reduced. Means here living organism, or it may be a non-living like water bodies, you have to take care of it. It's the toxic substances should not be exposed to these environmental parts. Okay, and environment is protected, so thereby environment will be protected if you do not let these toxic chemicals to be exposed to the nature. Maybe it is in atmosphere, or maybe it is in land mass, or maybe it is in water bodies. So here by taking care of all these aspects, you are going to develop the green chemistry and chemical knowledge for the production, and which is a sustainable development. So this makes it a most effective and least costly way of practicing chemistry. So initially you may have problem, but as the people started thinking of it, no doubt such lifestyle, such technology will surely be developed. And nowadays people are taking care of it. So green chemistry is sustainable mainly in the following aspects. Okay, so when you talk about sustainable green chemistry, then it focuses on three things. First is material. By the efficient use of material, maximum recycling, minimum use of virgin raw material, green chemistry becomes sustainable. Here it means that there should not be any waste material form, or if at all it is forming, there should be recycling of desired product as well as recycling of waste product, and minimum use of virgin raw material. Virgin means directly which you need to grab it from nature. Okay, so that should be avoided. So green chemistry becomes, then it becomes sustainable if you think about the material in this way. Then second point to be focused on is waste. By reducing the generation of waste as much as possible or zero waste, both cost of waste treatment and damage to environment are cut down. Means here why to think about the process and then let the wastage form, and then you start thinking or developing the technology how to minimize, how to reduce its effect. Don't think about it, just think about the process, just focus on the development of new methods in which there will not be any waste material formation. So that will help to cut down the waste treatment cost, that will help to cut down the damage to environment. So all these things will be minimized if you think about the new process, new green chemistry, you can say insight that will not allow to form the waste material. And third is economics. Efficient use of material, minimizing waste generation, both make process economical and more viable. Means if you take care of first and second point, obviously it will take care of third. So if you reduce the lot of consumption of energy. Obviously it is going to reduce the cost, and that will save the economy. At the same time it will save the environment also. So these are the three areas which are to be focused when you think about the green chemistry. So we'll go to the next point, that green chemistry and synthetic chemistry. So, what is synthetic chemistry? This word we have used many times in our chemistry. So, it is a branch of chemistry which involved in developing new chemicals and improving ways to synthesize them. Means sometimes you are trying to prepare new chemicals which will have a new desired or very useful properties. At the same time sometimes you may go for developing a method for known chemical, but the method will be new. That will be a green method, that will be a economic method, that will save the environment. So both the aspects are coming under synthetic chemistry. So synthetic chemistry, mostly if you talk about it, it is used in organic chemistry. Okay, so when you talk about green chemistry, means when you take into account the environmental aspect of the chemistry, the various chemistry branches they contributed to green chemistry. Okay, so here you can say analytical chemistry. Analytical chemistry has helped to develop or discover or to monitor the severity of pollution problem. Means the chemical pollution cannot be measured, cannot be gauged without development in the analytical chemistry. So that is a contribution of analytical chemistry. Then physical chemistry has helped to understand photochemical reactions taking place in atmosphere and suggesting means to prevent harmful atmospheric photochemical effect. So that is the contribution of air. There are n number of such contributions by various chemical branches. But as far as synthetic chemistry is concerned, they started to contribute green chemistry relatively late, because they were just thinking about the developing new material. For example, if you want to develop a new medicine, so while developing a new medicine, you have to develop the method. Sometimes you know the medicine, but you have to develop the new method. So both the either target oriented or method oriented, both the researches were going on in synthetic chemistry. So now the green synthetic chemistry has come up with the concept, this new concept. So other branches, as I told you, contributed to environmental study. Now time has come that synthetic chemists play their important role in environmental protection. So practice of green chemistry for synthesis of these exciting chemicals, means exciting means here means the chemical with very fascinating advantages or properties. So this chemical reduces these added cost. So if you try to develop such chemicals, such methodologies, then obviously it will reduce the added cost, that is to cut down the process waste treatment or damage to environment. So all these things will be taken care. So avoiding hazardous feedstocks. Okay, eliminating generations of dangerous intermediates and byproducts, and avoiding severe conditions that might lead to hazardous are the key principles of green chemistry. Means here hazardous feedstock should not be there. Okay, starting material. Eliminate the formation of dangerous intermediate, especially sometimes some danger, you can say threatening damaging gases may form, that may be effluated from chimneys. So and one more thing, formation of toxic byproducts. So all these are the main key principles of green chemistry, and these which has led to the reduction of production cost. Means uh, taking care of environment has not only has taken care of our life, our future generation life, but at the same time it has taken care of economic part also. There are generally two approaches to implement the green chemistry. Okay, so what are those two parts that is uh, mentioned or described in this figure? You can see here that environmentally benign synthesis of existing feedstock. Are you getting? So here either you can think about the new chemical, means for example, suppose if you are using a particular chemical for particular purpose. Okay, so don't go for that chemical which causes the environmental damage. So think about the new thing which may be available in nature. For example, if you want to use say pesticide, so pesticides are harmful, not only harmful to human being, but at that same time they develop the resistance in pest also. So after some time those toxic poisonous pesticides do not help. So think about something new which is found in nature and which is sufficing our purpose also. So either you can think in this first way or other way, that you go for the desired product only, but go for method modification. Substitute the chemicals made by environmentally benign process. Means here you have to modify the process, or you have to change the target molecules. Means both way, either method development or target chemical which will take care of sustainable green chemistry. You can think in both the ways. So first is use of existing chemicals but with environmentally benign method of synthesis, or entirely new environmentally safe raw material. So both way you can think about it. So the key concept of green chemistry is that of high atom economy. So what is atom economy, that you have to think? Means right, we are now hereafter we are going towards hardcore chemistry. Okay, and that is green chemistry. So first comes high atom economy. What is basically atom economy? Means see, in lab, when you go and prepare something, suppose in SY you are prepare thalamide from thalic acid. So you draw the structure of thalic acid, find out its molecular weight, how much weight should be taken, you take that much gram, follow the process and you get the thalamide. So one molecule of thalamide gives you thalic acid gives you thalamide. So by comparing the molecular weight, you decide how much should be the product if you take 1 gram of the reactant. So that you call it as a yield. So if as the value goes near to the uh, your theoretical value, the practical yield, as it approaches to theoretical yield, you say you calculate the percentage. So at the most you can have 100%. But in that process, conversion of thalic acid to thalamide, you are not taking care of where the nitrogen replaces the oxygen. But where that oxygen goes, what happens to that oxygen? You are not, while calculating yield, you are not taking care of that. So here atom economy is that whatever is your starting material, find out its molecular weight, find out its number of atoms, and within the same number of atoms you should get the product. Are you getting? Means here whatever number of atoms involved in the reactant, a maximum number of atoms should be used in the synthesis of product. That means there should not be any byproduct. So if the use of such number of atoms in the product goes on increasing, there if there is no wastage of uh, mm, product, there is no formation of waste product, then the atom economy increases and it becomes high. For example, here I have given one example that addition reaction. This you have studied in organic chemistry many times. It's a simple bromination. In lab you can do, just take any alkene, add to that, add bromine water, immediately it will get added. And what will happen here? Look at the reactants and look at the product. There is no byproduct. All the atoms which are used in the reactant, all the atoms are used or incorporated in product. So there is no wastage of atom. So that is called as atom economy. So for this particular reaction, the atom economy is 100%. So in this conventional method of synthesis, high yield is obtained when the reaction goes completion and starting material is consumed completely. However, in these cases, even if there is 100% yield, the byproducts generated can also be pose problems of disposal. Means if there are formation of byproduct, though there is 100% yield, it is going to create the problem. So atom economy refers to the fraction of all reagents that go into the final product yielding minimum or no byproducts. Means here reactant, whatever number of atoms in the reactant, that should be incorporated in building or constructing the product. So that is called as atom economy. And for this, especially for this example, there is 100% atom economy. So what is the theory behind it, how it is going to help, that we'll discuss in next lecture. Okay, so thank you, we'll stop here.